Hi. So for the mole concept, we have seen how to convert mass to mole, how to convert number of molecules to mole, or from mass to number of molecule, and the reverse also. So today we are going to see that how you're going to do the calculations of mole involved with the gas volume. Okay. Now, in order to understand that, we need to take some containers. Okay. The containers are filled with different gases. Like for example, here I have taken five containers, and in this five container I can see fluorine, chlorine, nitrogen, oxygen, and neon gas are filled. And this container volume is 24 decimeter cube. All the container's volume is 24 decimeter cube. Now, what I'm going to do, I'm going to fill the gas of these gases at room temperature pressure, RTP, or this is also called standard temperature pressure. What is this room temperature pressure and standard temperature pressure is taken? It's 20 degrees Celsius and 1 atm pressure for IGCSE curriculum. So there is a specific reason why I have taken 24 decimeter cube. I'll tell just in after 2 minutes. So all the containers are 24 decimeter cube and the gases are filled. All these gases are filled. Now, what you need to do, you need to measure the mass of this each gases. So let's measure, and you're going to find the mass of nitrogen gas is 28 gram at STP 24 decimeter cube. The mass of oxygen gas of this 24 decimeter cube, you are going to get 32 gram. So I hope you are able to link something. The mass of chlorine gas, I'm going to get 71 gram. So what is this amounts? Are these amounts are very common to us? Is it very well known to us? Yes, definitely. The mass of nitrogen is 14. So if I'll take nitrogen gas N2, it will be 28. So this is the MR for nitrogen. The MR for oxygen is 32. The MR for chlorine is 71. So these are the MRs. So that means the other gases like fluorine has the mass 19. So F2 will have 38 gram. What about neon? Neon has the mass 20. So 20 gram. So the gas masses is exactly equal to the MR. So that means it's a 1 mole gas, right? Because we know the formula, mole equals to mass divided by MR. So if we are getting the mass is exactly equal to MR, so that means 38 gram divided by 38 molar mass, so equals to 1 mole. So similarly 71 by 71, 1 mole, 28 by 28, 1 mole, 1 mole, and 1 mole. Very magical, very wonderful relationship we found. So 1 mole of any gas at room temperature pressure or standard temperature pressure is occupying 24 decimeter cube of volume irrespective of any gas. You can take any of the gas, like for example you can take a compound gas also, for example carbon dioxide. So 1 mole of carbon dioxide will occupy how much volume? You have to calculate the MR for carbon dioxide. MR for carbon dioxide is 12 plus 32, it's 44. So 44 gram. Okay, now this 44 gram is going to occupy how much volume? 24 decimeter cube. Irrespective of any gas, it's going to occupy one. If it is 1 mole, then it's going to occupy 24 decimeter cube. So this is about the gas volume. Now we can construct a formula from here also for our easier calculation. So mole will be equals to volume of the gas, volume, it should be in decimeter cube, divided by 24. Let's see one quick question to understand it in a more clear way. So let us write a question. Let's say 0.18 gram of water vapor will have dash volume? This is the question. So I need to find, look at the formula, I need to find the volume of the gas. So I need mole. So I can calculate mole from this mass of the gas, 0.18 divided by 18. So it will be equals to 0.01 mole. So now we got 0.01 mole. Let's put it in this formula. So volume will be equals to mole times 24. So now mole we got 0.01 times 24. So it will be equals to 0.24 decimeter cube. Or else you can write 0.24 into 1000 centimeter cube. So that means 240 centimeter cube, or 2. This is also decimeter cube for your convenience. Decimeter cube, 1 decimeter cube equals to 1 liter. 1 centimeter cube equals to 1 ml. So that means 240 ml, right? Okay. Thank you so much for watching. We'll see the stoichiometric calculation in the next video.